Hello everyone, we are Team COGNITIONIS. We are second year BTech students from Bennett University and we tried to design an indigenous face recognition and authorization system. What is face recognition? It is one of the several methods of what is called biometric identification system. In facial recognition, physical features of a person's body, specifically the face, are uniquely distinguished from one person to another. The system takes in data in the form of an image of an unknown person, analyzes the data in that input, and attempts to match them to existing entries in the database of known people's faces or voices. Facial recognition is implemented in 4 steps: capturing the image and resizing it if needed, extraction of facial features, comparison for the existing database, and matching. The most important step is the feature extraction. There are different peaks and valleys that make up facial features called as nodal point. A human face can have up to 80 nodal points. Some of the common examples of nodal points are the distance between the eyes, the width of the nose, the depth of eye sockets, the shape of cheekbones, the length of jawline, etc. For example, in the image we can see the girl's face on the left hand side is converted as a face print of nodal points on the right hand side. So why is facial recognition needed? It is needed for security purposes such as tracking, fraud detection, identification, etc. and for recreational purposes. It is an interesting fact that the filter face detection system algorithm used by Snapchat was originally developed by FBI. We shall focus on COGNITIONIS focuses on the security feature. We are providing an authorization system through face recognition. So what does COGNITIONIS do? It allows the user at the checkpoint to capture the image of the person passing by through the app and upload the image to the database. The database we are using is Firebase. Firebase provides an interface between the application on an Android environment and the server-side application on Python and TensorFlow. It is already in the database. It is now downloaded at the server side. It is run through a CNN. The CNN, which stands for Convolutional Neural Network, we use is Inception from GoogleNet. The CNN then helps to give the result as a profile percentage match of the different users, authorized users in the system. The result is then again uploaded in the form of a text file to the database, which is then downloaded at the checkpoint by the user to check the authorization of the person passing by. So here are some snapshots of COGNITIONIS. The first sample we are showing is of an authorized person. The image here is captured through the app and then uploaded to the database. Then the program is run and the image is recognized as that of Nandana Vashne with an accuracy of 73.66% approximately. We can see that the other users such as Vastav, Shivaji, Yashraj, Vishal match to some extent, but the maximum percentage goes towards the image of Nandana Vashne. The result is then displayed on the app with the percentage accuracy. Now the second sample we will see is that of an unauthorized person. Here the image of a random person is taken, captured by the camera. It is then uploaded to the database. The program is run and we see that none of the profiles match to a considerable extent. Thus the person is declared as not recognized and the user at checkpoint is told to try another image. This was how we implemented the facial recognition in a very naive form. The problems we encountered in face recognition systems so far were the variation of facial features over time, the improper lighting conditions. The results vary to a great extent depending on the background as well. the difference in colorful backgrounds and plain white background, the difference in good lighting condition and bad lighting conditions are very stark. And there is a very narrow margin for permissible error since the face recognition is used in a high-risk environment. This is all we have for you. Thank you.